Okay, so going further with our graphs and our transformations, right, let's say that I consider the graph of y equals cosine of x and y equals 2 cosine of x, shown here and shown here. Okay, notice that y equals cosine of x has a range that goes from -1 to 1, while y equals 2 cosine of x has a range that goes from -2 to 2. Okay, that distance from the central axis to the maximum or to the minimum, right? So that distance from there to there, right? Or that distance from there to there, from this kind of center line, right? From that distance from here down to here is called the amplitude, right? So the amplitude of y equals cosine of x is 1, because the distance from this central axis down to there is 1 unit. The distance from that central axis up to the maximum, right? That distance is 1. So that is the amplitude. Okay? While the amplitude for 2 cosine of x is 2, right? If I look at from that central axis up to there, that's a distance of 2, right? And that is what my amplitude is. Okay? Any vertical stretch will affect the amplitude, right? So really shouldn't say transformation, should really say any vertical stretch or compression will affect the amplitude, right? But a translation will not. Alright, so if all I do is take this graph, move it up, move it down, not changing the amplitude. Take this graph, move it up, move it down, not changing the amplitude. But if I do stretch or compress this vertically, alright, that's going to change the amplitude. Okay. So if we consider each graph, the horizontal distance between the two maximums is equal to 2 pi. Therefore, the period of the function is 2 pi. Right? So if I look at this and I say, hey, what is the distance from there to there? That distance to repeat itself is the period. And for both of these, that distance to repeat, for both of those, that distance to repeat is 2 pi. Okay? So how long it takes the graph to repeat its shape, that's the period. And here, 2 pi. Okay? If we were to compress or stretch any sinusoid horizontally, then the period of the function would change. Right? So here are your two graphs. If I look at from a maximum to a maximum, that period is equal to 2 pi. While if I look from this maximum, right, to that maximum, that period is equal to 2 pi over 3. Okay? I can also do that from minimum to minimum, right? So from there to there, we can look at that period, and that is 2 pi over 3. That's the time that it takes to repeat itself, the space that it takes to repeat itself, right? So on the left, period of 2 pi. On the right, period of 2 pi over 3. Okay? So the graph on this right is a sinusoid that has been compressed horizontally by a factor of 3. Right? What does this look like in terms of equations? Okay? Well, if the graph on the left is the cosine of x, right, because I'm starting at a max, and it's y equals cosine of x, right, so I can say, hey, this is y equals cosine of x. Okay? Then I can set this up, and I can look at this graph right here, right, and I say, hey, it also starts at a maximum, looks like a cosine function, but the period has changed, so this would be the cosine of 3x, because 3 times x represents a horizontal compression by a factor of 3, right? So 2 pi divided by 3 compressed by a factor of 3, cosine of 3x compressed by a factor of 3, right? So that graph y equals cosine of 3x. Okay? It's very important that we understand this, that we understand the period of a sinusoid based on the horizontal compression or stretch. So a period of 2 pi over 5, right, means that I compress by a factor of 5, while a period of 10 pi means that I stretched by a factor of 5, right? Why? Well, 2 pi divided by 5, my period just got smaller, while if I say 2 pi times 5, my period just got longer. Alright, so if the period gets longer, horizontal stretch. If the period gets smaller, horizontal compression. Those items are very, very important to understand in